This is lesson 31, VHDL example 17. In this example, we're going to do a 4-bit gray code to binary converter, just the opposite of the last example. And in this example, we're going to introduce VHDL variables. Now, you recall that we had this algorithm for converting a gray code to binary. So here's a 3-bit gray code to go to binary. Remember, we copy the most significant bit, then for each smaller one, the BI was the BI plus 1 exclusive OR with the GI. Now, we saw last time that 4-bit gray code to 4-bit binary could be implemented using this circuit shown here with the 3 exclusive OR gates, which implements this little algorithm we had before. So you might think that we could just use a VHDL for loop, as we did in the previous lesson, to implement this circuit. But it turns out you'd run into a problem, because if you look at this, you see that every time through the for loop, the new BI depends not only on the input G, but also on the previous B. For example, B1 depends on B2 and G1. But B2 got generated in the previous for loop. Now you remember in VHDL, this would end up being a signal assignment statement if we used signals. And the problem is that signals don't get evaluated till the end of the process, you remember. And so in that case, the B that you're dealing with wouldn't be the B, because it doesn't get updated every time around the for loop. So to solve that problem, we need to use what's called a VHDL variable. I show it here. Variables are defined inside of a process. So we have process G, and I'm going to define a variable BV, standard logic vector 3 down to 0. And then it's the variable BV that I'm going to assign to G3. Now notice that we don't use the signal assignment statement. Variables get assigned using the := operator. So the variable assignment operator is := so BV3 gets G3. And then we say for I = 2 down to 0 loop, BVI : BVI plus 1 exclusive OR with GI. Now, variables, unlike signals, get evaluated immediately, just like you would in a regular computer program. So when you go through this for loop, this variable BVI will get BVI plus 1, which is the previous one. So if you set B3 to G3, then the first time through the loop, BV sub 2 gets BV sub 3. Well, it's this 3 which is what you want, the G3, exclusive OR with G2. And then the next time through the loop, I will be equal to 1, so BV1 is equal to BV2, the BV2 that you executed the previous time through the loop. So variables get evaluated immediately. It therefore works. Now, when you come out of the loop, we want the output B, which is actually the output, then has to get assigned to BV, the variable which you computed. In this case, it'll generate the circuit that you, with the 3 equivalent exclusive OR gates, like we saw before. So variables are different from signals. They're defined inside the process. Signals, you remember, would be defined out here. But in this case, since we need to use the BVI plus 1 that gets generated each time through the loop, we must use a variable for this circuit to work. Now, if you simulate that with the gray code going from 0 to F, you see, in fact, you get the corresponding binary numbers. You can verify that this simulation produces the correct result.